Hello, everyone. Welcome to this closing keynote of PTCʻ22. Sorry not to be there with you in person. I think so is John. But without further ado, let's start this off because obviously energy use is an absolutely critical dimension of today's modern digital infrastructure that powers the global digital economy, which basically is about to cross the 50% mark as far as being the global economy, not just the digital economy. So we're very fortunate today to have, and by the way, there's a typo in your programs. It says that Jonathan is one of the leading data center energy experts in the world, and that's a typo. As far as I'm concerned, he is the grand master, the OG, the godfather.
The uber geek.
The Uber geek, thank you.
Yeah.
So the OG and the UG of data center energy and decarbonization and everything else you might be concerned with. So, John, can you just maybe give a little bit of background on yourself?
Yeah, so I've been studying data center electricity use for about 20 years or so, and I focused on computers even before that. I was a staff scientist at Lawrence Berkeley Lab, and roundabout 2000 or so, there were a couple of guys running around talking about how the internet was going to use half of all U.S. electricity, and that not debunking that nonsense led to a bunch of great work. Some of that work involved the first peer-reviewed measurements of data center electricity use, working with Michel Blazek at AT&T in the early 2000s. And that was around the time also when the internet was becoming a big thing. And electricity use for data centers actually doubled from 2000 to 2005. So there was a real focus by the industry on efficiency and figuring out ways to moderate that growth. And
yeah, so John, if I could just, this is my own background with your work is, back in the days of AT&T, when it was all manual operator switching, the whole point was that half of the people in the US would be involved in switching calls for the rest. And so they needed some sort of breakthrough. And so, for me, at least, and maybe for many other people, your story begins then where you just showed this exponential growth and everyone was freaked out that, the whole world was just going to be generating power to feed the machine.
Yeah, it was a real thing. I mean, the growth was happening rapidly. And this was, back in the day before people really had spent a whole lot of time to make these devices and institutions more efficient. So people focused on it. That's one of the great things about the tech industry is that when there's a problem, people, the smartest people in the world come together and they figure out how to fix it. And that's what happened in this case, because you started to see after 2005 or so, 2007, you started to see moderation in the growth of electricity use. You still had growth in the use of the computers. So this, what we call the service demand, was growing very, very rapidly, but things started to moderate on the electricity side.
Right. So the whole question is really not just what happens in aggregate, although that may be an important global issue, but the other key question is just what is the unit cost of energy for a given computation, right? Like, what does it actually cost you to add two numbers?
Yeah, and as you do more, ideally the cost would come down, right? As you learn more, you have learning by doing, and you have economies of scale, and so on. And so what tended to happen was these data centers got bigger and bigger. You ended up with better economies of scale. You started to see people shifting to hyperscale cloud computing configurations that led to higher utilization, lower cost per computation, lower energy use per computation. And so a lot of that growth in service demand has been offset by these efficiency improvements that came from innovation, not just for servers, but also for the design and construction of the data centers themselves.
Right. So first of all, there was the move to state-of-the-art data centers out of perhaps less efficient data centers. Then presumably there are things like moving to, away from coal to natural energy. But then, as I recall, there were a variety of technologies that you saw being deployed that made a significant impact in your Lawrence Berkeley DOE report back, I don't know, 2017 or so. So like server idling and use of the cloud. So can you just say more about the impact that that had?
Yeah, so you had improvements on individual components of data centers. So you had the chip manufacturers and the server manufacturers figured out how to get the idle power of their servers down really, really low. So that meant when it wasn't doing anything, it also wasn't using as much power. In the olden days, when I first started working on this, it was pretty much flat, right? There might have been a little bit of change as you increase the load on the server, but it wasn't a big effect. But they did a lot of things to make the servers responsive to load. They did a lot of things to use more outside air and reduce the infrastructure energy use in these big data centers as well. And that turned out to be a pretty big effect. Just shifting from a traditional corporate facility to a hyperscale facility got you the benefits of having the latest, greatest server tech, but also better PUE. So the infrastructure was a lot less energy intensive. Then you got economies of scale. Then you got these diversity benefits that you and I have been chatting about for a while, because you have more users and more different kinds of users. So you can spread the loads over the whole day. And that means that your utilization of your equipment is much, much higher. And that turns out to be one of the most critical things for reducing cost per computation and energy per computation. There's a fixed energy use for some of these devices. And if the more computations you do, the more you can spread that fixed energy use per computation. Same thing for the cost. There's a huge fixed cost. So if you do more computations with the same gadgets, you end up with a much lower cost per compute. And for cloud computing, it's a 10 or 100-fold improvement in cost per compute. And that's a huge reason why people are shifting a lot of their corporate facilities towards these hyperscale installations.
Yeah, and I would imagine there's also these like secondary effects, like people who site their data centers in Iceland or run clouds out of Iceland, where they can run on geothermal and be cooled because there's a ton of snow outside.
Yeah. So that has kind of a second order effect on the energy use too, right? It's cold air that you can pull in, right? So that's great. But the energy side, there's lots of renewable power almost everywhere. So to the extent that you can source more renewable power, that means the emissions per compute is going to be lower than if you were using more conventional fossil fueled generation plants. And that's a big deal because the hyperscale providers are big enough that they can actually go out and they have their own teams of people whose job it is to identify good sources of renewable power and build those projects. So they're building additional renewable power that wouldn't have gotten built otherwise, because they know that their customers care about whether they're, doing their computations in a clean way. And that's been a very important part of the renewable energy market, is the driver that comes from the tech companies.
So there's a virtuous cycle there. And so what you're saying is there are really, several things that we need to be worried about. It's a multidimensional problem. One is aggregate energy use across all computations that may exist. The second thing is the unit amount of energy for a given computation. And then regardless of how much energy you use, you've got to worry about also the source. Is it
That's right.
Renewable and or clean, and or is it just dirty and high carbon emission issues associated with it?
Yeah, that's right. Exactly right.
So this session was advertised as things that you know about data center energy use that are wrong. So what is it that everyone gets wrong?
Well, I think the biggest thing is people think that the economic importance of computing means that it has to use a lot of electricity. And we know that it's important. That's absolutely true economically. But what we've seen from 2010 to 2018, which is the latest data that we have, what we published in Science about 2 years ago now, what we saw was that there was growth in the computational demands, the service demand. You had The data center workloads were 6.5 times bigger in 2018 than they were in 2010. IP traffic was up 11-fold. Storage was 26 times bigger in terms of gigabytes over that 8-year period. But electricity use for all data centers went up 6%. So massive increases in the service demand, but very modest increases in electricity use.
Yeah, I'm sorry about that growth in storage demand. I know I have some photos that I need to delete that were.
It's your fault.
It's
your fault.
Exactly. So yeah, so that's a great point, right? Because we're balancing out two things, which is increased use against enhanced efficiency.
Exactly.
And so, you can't just look at overall demand. The other thing, and I know about 10 years ago or so, there was the power pollution in the internet expose that came out by the New York Times, and the Times basically said, hey, this is horrible. Data centers use electricity. And, isn't that horrible? And, my rebuttal to that at the time was that you can't just look at, the energy and computation side of it. It isn't just the global economy in terms of, hey, we really want to be able to, have people be able to go on Twitter or do virtual conferencing. The point is that, for example, right now, we're using a lot of electricity, right? There's my laptop, there's my ring lights, there's the network between us, there's the Zoom cloud servers and so forth. But the carbon footprint through digital substitution is a lot less than it would be if I hopped on a plane and was burning, jet fuel back and forth.
Right.
And then the other, advantage is optimization advantages. So to the extent that you can run a computation and use that computation to then actually save some amount of use. So what a good example I think is the UPS Orion system that optimizes truck fleet routing, and it's computationally intensive. It's solving a computationally intractable problem, but it's also, enhancing labor productivity, reducing the amount of manufacturing that needs to be done on trucks because they don't get worn out as quickly, reduces carbon footprint and energy use. So, there are these other effects that say, it's great to spend one stitch on data center energy if you can save 9 stitches, on, some other real world problem.
Yeah, this is a really important point. The correct question is always compared to what? Right. And so, yes, you can offset a bunch of other activity in much more energy intensive parts of the economy using a relatively small amount of electricity. So in 2018, data centers were less than 1% of the world's electricity use.
Wow.
So a small number. If you add all ICT together, it's 3 or 4%. And it's not growing very rapidly. So that's, what happens. People forget that new devices come in, new uses come in, but old ones go away. They get displaced. And so part of what happened for data centers was the old uses, the corporate data centers, super inefficient, were being displaced by hyperscale facilities. And so those hyperscale facilities were so much and are so much more efficient than the corporate data centers that they could increase the computational load 6-fold, but keep electricity use flat because we're basically displacing this really old, inefficient infrastructure. So people need to remember, it's not all about the fast-growing part of the system. You got to look at the whole system. And if you don't look at the whole system, you're gonna make mistakes. You're gonna miss the overall effect. You're gonna pessimize the system. That's not good.
Right. So that though brings up an interesting question. And edge is very hot right now. And depending on who is doing the counting, you can come up with wildly different estimates. But the usual estimate as to what's around now, different people would say there's tens of billions of endpoint devices, smartphones, smart TVs, Hue light bulbs, connected refrigerators, connected autonomous vehicles, et cetera. And by my estimate, I see 1 trillion as being something that will come here sooner rather than later. Because if there's 8 billion people in the world, and even if you only consider consumer uses to be, say, half of the uses, In my own household, I've got 6 or 7 smart TVs, 10 ALEXAs. I can't say her name because she's listening in right now. Laptops, monitors, Nest cams, and so forth. Smart outlets. And so I easily have 80 or 90, and I'm not even, I'm not a Stacey Higginbotham or anything, that's pushing the envelope. And so if you say that, every person out of, 8 billion has 100, you get up to 800 billion, pretty quickly. So the obvious question is, with all of those endpoints, and with a shift to interacting with those endpoints, going away from the hyperscale facilities and going to the edge, what do we think is going to happen? Are we seeing any trends there, or are you monitoring that?
Well, so this is one of the big questions, and what ends up happening is you get limited by the data that people collect, because the interesting new stuff is the stuff about which we know the least. And so we know that the edge area is growing rapidly. We have the usual kind of hype stuff from the participants in that, but what we don't have is really solid data on that. So I think it's absolutely growing. The question is it displacing central data center computing, or is it a totally new set of demands? And I don't think we know the answer to that. The other thing I would say is, as computing is dispersed more and more to mobile devices, there's a premium placed on the efficiency of those devices because they're battery powered. And there's also a premium placed on transmitting just the data that you need, because there's limited bandwidth for those things. And so what ends up happening is there's a certain set of constraints that lead to high efficiency for a lot of those endpoints. Not all of them. Like an autonomous vehicle obviously is going to have a lot of data transfers and use a lot more power. But for these smaller devices, even though there's billions of them, they're not, your smartphone uses 3 kilowatt hours a year. Your iPad uses about 12. So that's, 12 cents times 12 kilowatt hours times, 10 cents a kilowatt hour is $1.20, right? I mean, that's how much you spend on electricity for your iPad every year. Maybe it's $2.
Even less because I keep mine off all the time. So
okay, there we go.
I get your point. So real quick, since we're almost out of time, any thoughts on crypto, Bitcoin mining, and what is that, artificially inflating something, or?
Well, so I don't comment on whether crypto is a good idea, whether it delivers any sort of service. That's the question that other people can address.
Okay.
But we know that it uses electricity, and it's in the tenths of a percent. Something around 0.5% of the world's electricity is crypto. That's not in the data center number that I gave you, right? That's a separate thing. It goes up and down. There's a thing called the Cambridge Bitcoin Electricity Consumption Index, CBECI, which is the kind of source for these estimates. But here's the thing about it. We really don't understand these systems very well. The low and high estimates from the Cambridge numbers, factor of 10.
Okay, great.
Okay,
that's like saying I'm going to live between now and the next 500 years.
Right, so there's a lot of uncertainty in those numbers. The main point I'd like people to come away with from this conversation is, if you hear an amazing factoid that says data centers or ICT or crypto or anything else uses, massive amounts of power, like 50% of the world's electricity, or it's going to grow to that in 5 years, assume those numbers are wrong. Okay. Seek out the people who have actually studied this, who don't have an interest in hyping it. And then, come talk to us and we'll help you understand it. But the problem is, people just hear this great gee whiz statistic and they say, wow, this is so fascinating. I'm going to send it to all my friends. And pretty soon, misinformation is spread around the world.
Well, I'm going to stop doing that then, since So on that note, John, thank you so much for all of your insights. And I think that this officially closes the conference. This ABC free cup for buying $100 worth of ABC suntan lotion over the years is the closest I'm going to get to Hawaii. So for those of you that are there, enjoy and have great travels home and stay safe. Okay. Thank you so much.
Cheers.